Uh, Hello, everybody. My name is Anton Gething. I am a product manager for Cloud Bigtable, and I'm very pleased today to present Cloud Bigtable in more detail to you. For this presentation, the agenda starts off with an introduction to Cloud Bigtable, where I will highlight some of its capabilities. Following that, we'll look at a very brief technical overview to give you some more detail on the concepts around Bigtable. And closing out, we'll look at some specific customer case studies, as well as their solution architectures, including some migration of customer journeys, migration journeys from existing data solutions to Cloud Bigtable. So, Cloud Bigtable introduction. For those who may or may not be aware, this is where Cloud Bigtable as the key value data store resides within Google Cloud database portfolio. I won't go into detail of the other databases, but I think as an overview, this gives you some idea of Google Cloud's database solution offerings and where Bigtable resides as a cloud native database. So what is Cloud Bigtable? So some may be aware that Cloud Bigtable is actually based on the original Bigtable technology that supports several billion user Google products that are available today, like search and Gmail and YouTube. Scalability and high throughput are key to the original design and implementation of Bigtable. So your application will not exhaust the capability of Cloud Bigtable, and we allow you to easily scale to meet the demands of your application. Cloud Bigtable is today supporting customers with millions of queries per second. As a managed service, a fully managed service, it frees you and your team up to focus on implementation that is more necessary to your business value, as opposed to having the management overhead of looking after your data solution. Interestingly and importantly, Cloud Bigtable from the start, the cloud implementation is completely compatible with the existing Apache HBase setup, which enables seamless migration from an existing HBase setup and compatibility with many other Apache services, and something that will be highlighted again when we look at the migration. So what is unique about Cloud Bigtable? Cloud Bigtable is the most price-performant database at scale, and it's important to unpack each one of those. As I mentioned, Bigtable from the start was designed for exceptional throughput and storage capability for large data solutions. Its replication model provides zero-touch, high-availability failover, and this is integrated and tuned as part of the Bigtable implementation. Another unique factor is that Bigtable provides workload isolation. This is incredibly useful for customers with replicated instances who would like to separate out different workloads on the same instance. For example, you may have batch serving, while in another instance, another cluster, you may want to provide serving path applications. And with this separation, you can ensure that different workloads don't disrupt each other, particularly serving path workloads. And then just finally, as I mentioned, Bigtable was built for petabyte scale, and it's earned its reputation with globally available Google products like Ads and YouTube, Search, Maps, and Google Analytics. So what is Bigtable good for? There are a number of use cases that align with Bigtable's unique capabilities to support your business requirements. Where multiple data sources are involved in your data pipeline, leveraging structured or unstructured data in large volume with high throughput and low latency requirements, Bigtable is an ideal solution. Personalization, the matter of personalization, delivering a tailored experience to each one of your customers corresponding to their needs, their preferences in real time to create a relevant and individualized experience for your customers. At the heart of this capability is data. To deliver personalization at scale, your application will need to store and manage and access large volumes of data, not only customer data, but also aggregate data points from other sources, leveraging machine learning and integration with other tools for a deeper understanding of your users' behavior. And this is where Bigtable provides an excellent data source to support this type of application. Fraud and event detection, too, is again, this time, real-time management and analysis of large volumes of data, potentially from multiple data sources, allowing you to see beyond the individual data points and uncover difficult to detect patterns and to identify risk and fraud patterns in order to quickly respond in real time. Data fabric is an interesting idea and is described as a single environment consisting of a unified architecture, services running on that architecture to help organizations manage their data. The ultimate goal of data fabric is to maximize the value of your data and accelerate the digital transformation. Data is consolidated from multiple heterogeneous and fragmented sources. And here, Bigtable provides a very cost-performance solution as the backbone to your data fabric. And along with global replication, can support services anywhere you are. Another good application for Bigtable is IoT or IIoT solutions that require low latency write and read of high volume time series or data device telemetry. Beyond capturing the data is building the analytics and the application on that data. And later we look at a use case where a customer has implemented an IoT solution on top of Bigtable. Lastly, customer and product metadata applications. This could easily be coupled with personalization, but is also applicable to the high volume analytics and machine learning applications, particularly around ad technology and marketing analysis, where customers require speed of their data in order to make business critical decisions, particularly in things like advertising bidding. And we'll touch again on some of these areas later on in the presentation as we look at the use cases and the migration. So what can Cloud Bigtable offer you? If we look a little bit more at the Bigtable capabilities, in addition to the speed and scalability that I've mentioned, it's a fully managed service. As you will know, managing your own database can be very costly and time-consuming, not to mention the potential of cost due to failures or outages, system updates and upgrades. With Bigtable, customers can focus on their application development and innovation, not managing services, patches, infrastructure, backups. Many Cloud Bigtable customers don't have any need for a dedicated operational IT staff. Performance of Bigtable can be quickly adjusted, and Cloud Bigtable optimizes your data automatically over time for best performance. Capacity as well for scale can be quickly added. So we can look into these items individually in a little bit more detail. Some numbers around speed in particular, as I've mentioned, Bigtable technology already powers billion user Google services. Bigtable provides sub 10 millisecond latency, making it a perfect fit for real-time storage and analysis of huge data sets. It also provides consistent throughput and latency as your size grows. So on the scalability size, as you scale, you can be assured of consistent throughput and latency with that scale. Talking of scale, two things I wanted to highlight here, particularly with scale, is the linearity of Bigtable's scalability. So Bigtable scales linearly. It was built for scale from the start. As your application performance requirements grow, as you grow, Bigtable can grow with you without compromising performance. I think another point that's interesting here and important is that in order to scale, you can simply add additional nodes. So a concept that was introduced here, introduced first, I think, in this presentation, is a Bigtable cluster and Bigtable nodes. And we'll go into a little bit more detail, but just to mention here that a Bigtable cluster is a collection of nodes, and nodes are the compute resources that manage your Bigtable instance. And as your Bigtable requirements grow, adding additional nodes adds to your compute resource, linearly scaling with your performance needs. Here, I want to talk a little bit about throughput and how these nodes and clusters operate. Through Bigtable separation of processing or compute and storage, Cloud Bigtable is able to easily automatically configure throughput by adjusting the association of nodes and data. In the example here that we talk about, in order to not compromise throughput, as your application scales, Bigtable rebalances. If node A is experiencing a heavy load, the routing layer in the Bigtable stack can move some of the traffic automatically to a less heavily loaded node and continue to maintain and improve performance. Resizing too comes into play where additional nodes are added, and again, Bigtable automatically balance the load across the nodes, ensuring overall throughput is maintained. Here, I'd like to talk a little bit more about these concepts that I mentioned briefly. So, as I mentioned, a Bigtable instance has a number of clusters. Those clusters are made up of nodes. And here, when we talk of replication, replication is replicating a Bigtable cluster. And with Cloud Bigtable replication, you can write data to any replica, any cluster, and it will automatically be replicated everywhere. There are no manual steps here. Bigtable replication is automatic and managed for you. It just works. There's no need to repair data or synchronize data. It is eventually consistent across clusters, but you can trust Bigtable with low replication latency to catch up quickly as your data is replicated across clusters. And I'm going to go into a little bit more detail now about replication and high availability. So replication in more detail, you can see here, it allows you to distribute your data across multiple regions, providing high availability, allowing customers to fail over in the case of either a zonal or regional outage. And it allows you to isolate serving and batch workloads, something I mentioned earlier. You are able to isolate your workloads between clusters, having clusters manage certain workloads like batch, or another cluster managing a workload for your serving path. It also helps, importantly, for customers who have a global user base. You can provide the low latency serving in your particular region. So a Bigtable cluster in a particular region will provide locally low latency access for those customers. Some other characteristics of Bigtable replication that I'd like to mention. A replicated Bigtable instance is multi-primary, so that you can write your data to any cluster and Bigtable will automatically replicate your data across clusters. I think this is important so you don't have a master. Each cluster is a multi-primary cluster, meaning you can write to any of the cluster and Bigtable will automatically take care of replicating your data across the Bigtable instance. Adding an additional cluster requires no operational overhead. The moment a cluster is added to Bigtable, it immediately starts to synchronize the data across clusters. The Bigtable SLA is 99.9% for one cluster, 3 nines for one cluster, and 4 nines of availability, 99.99% for replication of 2 or more clusters with multi-cluster routing. Here, I'd like to talk a little bit and briefly about Bigtable's integration with other Google services. It provides seamless integration to a number of other GCP services to support your application requirements like analysis, BigQuery, data transformation or migration with Dataproc and Dataflow. In addition to that, Bigtable has an extensive ecosystem of integration that includes a number of open source integration options for additional capability like streaming, time series data, geospatial analysis, and more. In particular, again, I'd like to call out something I mentioned earlier, the Bigtable compatibility with Apache HBase. For those familiar with Apache HBase API, this can significantly accelerate the ramp-up of Bigtable understanding and implementation, but it also supports the speed with which HBase to Bigtable migration can happen. Next, we go into a very brief and high-level architecture overview. So here, I'd like to talk a little bit about how Bigtable stores data. And there is more documentation around this on the Bigtable site. Bigtable is a three-dimensional data store with a single index, the index being the row key. Bigtable is a sparsely populated database, which means that you do not need to have data in every cell within the row. For cells that are empty, it takes up no space in your data storage. I'd like to talk about cells in a little bit more detail. You can see here that a cell is accessed through the row key, the single index row key. And if you need to get to a specific cell, you use the column qualifier and column family. Every cell is time-stamped for versioning. That happens automatically. And all data in Bigtable is raw bytes. The only time Bigtable tries to determine the type of data is for increment operations, where the target must be a 64-bit integer. But other than that, Bigtable data is stored purely in bytes. The ideal size for a cell should not exceed 10 megabytes. If you need to store larger blobs of data, it's a good idea to look into Google Cloud Storage. Here, I'd like to go a little bit more into the architecture where we can focus on Bigtable nodes. Adding additional nodes as compute units to your Bigtable instance increases the performance capability to accept more traffic for your Bigtable instance. You'll notice that the node data is stored on Colossus, which is Google Cloud's internal storage platform. In addition, writes to Bigtable are stored on a shared log for increased data durability. Here, again, I'd like to call out that nodes, though, themselves do not store any particular data. The nodes store indexes to chunks of rows called tablets. And so what this means is that node failure does not result in data loss. It also means that rebalancing can happen very efficiently, since any time a node is lost or nodes are added, it is a matter of redistributing the metadata or the pointers to the tablets. And this, too, facilitates really efficient recovery. Should anything happen, bringing a node back up is simply copying over the appropriate metadata and pointers to point to the correct tablets. So on this level, Bigtable is incredibly efficient at managing the data, lending itself to the capabilities mentioned earlier for low latency and high throughput. Okay, let's get into the case studies in a little bit more detail. So where is Bigtable being used today? So we have a number of customers, hundreds of customers. I've identified 6 areas that I think may be of interest, where there are particular use cases being applied at the moment. Advertising technology, where personalization, marketing analytics, and bidding requests are implemented. Retail, again, personalization, catalog management and search. Financial technology or financial services, where user and account data is being managed, and in particular, anomaly detection is being used for a number of customers with Bigtable. In the technology space, we have a number of use cases around real-time decision-making, monitoring and performance for data insights, IoT for smart meter telemetry and predictive analysis. And then with media and entertainment, we have streaming media analytics, media playlist management, and catalog management. So what I've done for use cases is I have 2 use cases for ad technology, another use case for IoT, and another use case for media and entertainment. And then as we move into the migration section, for migration to Bigtable, I have 2 case studies for migration. One for financial technology, a FinServe company, and another for a media and entertainment company. And these are all customers working with Bigtable at the moment. So firstly, ad technology. This is an ad technology customer who has a solution on Bigtable for real-time ad bidding and analytics. And the reason the customer is implemented on Bigtable is based on the unique capabilities that I've mentioned previously around performance. This customer required consistent, low latency, high throughput to monetize the ad campaigns. And as you can appreciate, anytime there is a compromise in performance, it'll have a revenue impact on their business. In addition to that, scalability and reliability were very important to the customer. They needed the platform to simply scale to handle peak traffic. And in addition to that, integration to other GCP products for real-time sophisticated analytics. And here we can see a very high-level overview of the solution architecture. This platform is handling over 800,000 queries per second, 80 million page views per day. There are a number of other GCP services that form part of this pipeline, where Bigtable is serving the ad bidding servers, Bigtable SSD instance, and BigQuery is being used for analytics and dashboards on Bigtable. Another use case in ad technology, this customer is providing a solution for real-time ad serving. So this is a different customer that's actually serving up ads. And again, this customer, in order to serve the ads, required consistent low latency, sub 10 millisecond P99 latency, with the ability to scale and support peak traffic. As you can imagine, traffic patterns vary daily depending on advertising, depending on the customer platform. And so Bigtable needed to scale seamlessly to support this load. In addition to that, the customer required regional availability with zero-touch high availability failover in order to ensure that they could support their ad serving business. And importantly, as part of this, Bigtable integrated with Memcached provided a low latency and very cost-effective solution for this customer. So at the moment, this customer, you can see here, high-level architecture with Memcached integration to Bigtable. This solution is currently doing around 150 billion ad requests per day with an average of 1 million requests per second. The memory store for Memcached integration provides not only the performance, but scalability and cost optimization, which was valuable to this customer. The database itself, Bigtable, needed to handle requests, as I mentioned, at sub 10 milliseconds for P99 with a median of less than 5 milliseconds. And so any impact to that serving performance would have a significant impact on revenue for the customer. And they have successfully implemented on Bigtable and continue to support this level of performance with no problem. So here's an example of IoT, where a customer has an IoT solution on Bigtable for predictive maintenance of their machines that are providing sensor telemetry, so a high throughput, low latency ingestion of sensor telemetry from a number of locations. This customer was very keen on the reduced operational overhead as well as the OpenTSDB integration to support time series data. And on top of that, the ability to integrate into some machine learning tooling for the predictive analysis. Here you can see an example of the high-level architecture for this solution. This solution is currently managing 1 million data points per second. And I think importantly, as part of this data pipeline, Bigtable is supporting not only the data ingestion, but then too, on top of that, the analysis, where once analysis has happened, the data needs to be queryable within 200 milliseconds at P99 in order to support the predictive algorithms required for the predictive maintenance that this customer needs in their application. And finally, as for use cases, we look at we're looking at a retail real-time personalization example. So for this customer with a very large online e-commerce presence, it was incredibly important that this customer had very high throughput, low latency for ingestion for event data, and then a consistent low latency for the serving path. Analysis and calculation on the data coming in is conducted real time and uploaded into Bigtable in order to provide a personalized experience for this customer's users as they move through the site. Again, scalability was very, very important. Bigtable needs to be able to scale to support different peak in traffic, different spikes, as you can imagine, with online shopping that varies not only daily but seasonally, as well as the spikes and increase in traffic you see for holiday periods. Again, replication has proved invaluable for this customer to support their business continuity and disaster recovery scenarios with zero-touch, high availability. And not only that, but the regional availability for low latency serving for where their customers are located. This is a surprisingly simple architecture, but very effective for the customer. Data flow ingests real-time user events, and the computed event data through data flow is put into Bigtable and made available for low latency serving path personalization through the clients which access Google Cloud Compute Engine, accessing Bigtable through Google Cloud Compute Engine. Next, we'll talk about some of the use cases, but particularly around migration and modernization with Bigtable. So Bigtable supports a number of migration efforts from other data sources, but two primary migration journeys that we've supported with a number of customers successfully are from HBase and Cassandra. We do and continue to support migration from a number of other data sources like DynamoDB, Cosmos DB, MySQL, and others. And these migration efforts are conducted either from on-prem to cloud or from cloud to cloud. But I should note, and as we go through these different steps, every migration is different. Every migration will vary depending on the customer workload and the customer needs. So looking at HBase migrations in a little bit more detail, there are two overriding vectors for HBase migration, either a migration that for the customer's business requires no downtime, where the customer can tolerate no break or disruption in service, or we have an offline migration where some downtime is acceptable. The steps that I'll present here are primarily focused on the migration where some downtime may be acceptable, but we've conducted a number of use cases where online migration use cases where we've managed to migrate HBase over to Bigtable with no downtime. So these are the very high-level steps in order to facilitate a migration from HBase to Bigtable. Very important is to plan the migration, understand and evaluate all the HBase parameters that the existing workload has implemented in order to ensure parity and correlate with the Bigtable implementation. Then the next couple of steps, the next 3 steps, are essentially getting the HBase data into Google Cloud Storage. Once the data is in Google Cloud Storage, GCP or Google Cloud Platform tooling like Dataflow can easily take that data, upload it into Bigtable, at which point the migration is complete, and you can conduct some verification, and the workload can continue to operate. So here, just the migration steps in action. Once the migration's been planned, export the data to HDFS files into GCS, Google Cloud Storage. From there, leverage Dataflow into Bigtable. Once the migration has been verified, the customer can continue to use their existing application on Bigtable. The amount of effort from the customer to adjust their clients accessing the data is either negligible or none, depending on how they are using HBase. But due to the HBase compatibility, customers have experienced very little disruption to their clients as they moved from HBase to Bigtable. As an example, we have a financial technology customer who has a global presence for fraud detection. This customer saved 80% on their total cost of ownership in moving from HBase over to Bigtable. The workload that they have supports petabytes of customer data from around the globe, and they have a high volume of queries for real-time fraud event detection. And the reason they moved over, we can hear from the customer that they started to encounter a number of operational and performance bottlenecks, and subsequently challenges around the stability of HBase. And based on that, not only the management overhead, but also then the scalability and availability of Bigtable, global replication at scale was very important to the customer for this migration, and they're now successfully using Bigtable. The next migration to talk about is a Cassandra to Bigtable migration. Cassandra migrations are a little bit different. They have the same, 2 of the same categories, one where downtime is acceptable, another where online migration is necessary and no downtime is accepted. In addition to that, there are some other unique implementations of Cassandra where you've got a split workload. Either you've got a batch workload and a global serving, so 2 Cassandra rings serving different workloads, and the migration of those 2 clusters over to Bigtable. And then also a unique Cassandra implementation where the data is very transient and exists with a TTL or a time to live on Cassandra. And depending on those characteristics, the migration might be slightly different. But what I'll present here are the high-level steps. Actually, it's quite simple for migration to Cassandra with no downtime. It requires an implementation of dual write. The data is then copied from Cassandra to Bigtable. There is a verification. It says optional, but we normally do that in order to verify that the data and the migration has happened successfully. Once the migration has happened and we verified, along with the dual write, we start redirecting reads to Cloud Bigtable. Once all the read traffic is on Cloud Bigtable, the dual writing is stopped and the migration is complete. So these are very simple steps. There is some disruption to the clients accessing the data, which where different to the HBase compatibility, there is some compatibility friction in moving your data from Cassandra to Bigtable, where clients will need to update how they're accessing the data. The disruption isn't so significant that it's prohibitive, but you can expect to do a little bit of work there. And here we have an example of a customer in media entertainment who saw a 75% drop in cost with their migration to Cloud Bigtable. This customer had hundreds of Cassandra clusters with over 3,000 production machines, managing 150 terabytes of data with an average of 4 million queries per second. And the reason the customer moved over was performance and scalability, as I think the operational overhead of managing that size Cassandra implementation was very costly for the customer, indicated by the fully managed sort of reduced operational overhead of capacity planning in their move over to Bigtable. Cost, as I mentioned, played a significant part. And then integration, which was very valuable to this customer, since in the migration, they now have access to a number of other GCP services to leverage technology that would have otherwise not been available on a self-hosted solution. And that is the end. Thank you very much, and I look forward to any questions.